We're going to continue with the exercises on parabolas. We're on exercise 2 from the handout on parabolas. And in exercise 2, we're going to graph some parabolas, labeling the focus and directrix. Now, these graphs, actually graphing the parabolas should be pretty easy for you guys, because we're very familiar with these quadratic functions and some of these equations that are related to quadratic functions. For instance, in A here, you know, that's really a form of y equals ax squared plus bx plus c, where the coefficient a is 1/20th, and we could say b is equal to 0 and c equal to 0. So that's a parabola whose vertex is at 0, 0. And because the a coefficient is positive, we know it curves upward. So we actually can draw a rough sketch of the graph without even plotting any points, because we know the vertex is at 0, 0. But what's new for us here is we're now going to label and find the focus and the directrix. So to find the focus and the directrix, we need p, the p constant. And so we're going to use the standard form of the equation, which is, in this case, it's always, one of the variables squared. So we have x squared here. I'll write x squared equals 4p times the other variable not squared. So we're going to use x squared equals 4py. To do that, so to make use of this, I need to take my equation and convert it to that standard form, right? So I'm going to bring that around here, and I think you can see we can multiply both sides by 20, and I can get that equation into the form x squared equals 20y. And then I compare the coefficient of y in the standard form to the coefficient of y in my example. And what we see is that 4p has to equal 20. So divide both sides by 4p is equal to 5. And now, again, the p value alone doesn't tell us exactly where the focus is. But because we already know the shape of this parabola, I know the focus is on the y-axis. I haven't even set up a scale here. I'm just drawing this as a rough sketch. And I know this focus point has to be 0, 5 for this parabola. And I know the directrix is always going to be, in this situation, parallel. I'm not drawing it as straight as I could. I should use a ruler, shouldn't I? There's my directrix. And that's going to be y equals -5. Y equals minus the p-value. So that's all we want to do. Sorry for the sloppiness here. Just a rough sketch of the parabola with the focus and the directrix label. That's part A. Let's go ahead to part B. Is from our handout, x equals 1/4 y squared. And we want to do the same thing. We want to sketch a graph and label the focus and directrix. Now, because I see y squared, that's telling me, that's my indication that I have a sideways parabola. And so it's either going to curve to the right or to the left. My standard form for when I have x equals x to the first power y squared is y squared equals 4px. And so I want to convert this equation to that standard form, multiply both sides by 4, I get 4x equals y squared. And so I can rewrite that with y squared on the left equals 4x. And I'm going to equate the coefficients of x. So I know in this situation 4p must equal 4. So p has to equal 1. And so let's imagine a graph here. Now when p is positive, the parabola is going to curve to the right. When p is negative, it curves to the left. I guess we got to know that distinction. You could always plot some points also to check this out. The vertex is going to be at 0, 0 for all of these. Because p is positive and I'm a sideways parabola, I'm going to curve to the right. Just draw a rough sketch. And the p-value of 1 is telling me that my focus is at 1, 0 on the x-axis. And my directrix, well, I'm going to learn my lesson from last time. I better use a ruler. Is going to be a vertical line, so its equation is x equals a constant, x equals -1. So there's the directrix, the focus, and a rough sketch of the graph of the parabola for part B of number 2. And then part C, I think there's one more. Y equals -2x squared. I would say here's another example where I think you can draw a graph, a rough sketch of the graph at least, without having to do much more than just sort of look at this equation. We have y as a function of x. So we're going to have a parabola that opens upward or downward, but because the coefficient of x squared is negative, we know it curves downward like this. And so we know the focus is going to be somewhere on the y-axis, and the directrix will be parallel to the x-axis. And now I gotta make use of my standard form. My standard form would be x squared equals 4py. And so while this is a form we love for plotting points, it's not such a great form for standard form, right? I need to take that equation and I need to divide both sides by -2. That's the same as multiplying by -1/2, so I get -1/2 y is equal to x squared, and then I want to rewrite it with the x squared on the left, -1/2 y on the right, just so I can compare again to the standard form. And here's another case where there's a fraction coefficient on y. So I have -1/2 equals 4p. And it's perfectly okay if you multiply both sides by 2 and then divide, but I'm going to go ahead and just multiply both sides by 1/4. So I can do this in one step. 1/4 times -1/2 is 1/4 times 4p. And I get -1/8 is equal to p. And I know that my focus is on the negative y-axis. Notice how this came out to be negative. So this is the point 0, -1/8 is my focus. And my directrix will always be that opposite value from the number we see in the focus. So if the focus has a negative coordinate, the directrix will be positive. It's like minus a negative is positive. So y equals 1/8 is the directrix. And we got again, the graph was fairly easy. It was adding the coordinates of the focus and marking the equation of the directrix that required that we work with that p form, the standard form of the equation with the p constant involved. Okay, so that's exercise 2. We got just a couple more here before we're through. Exercise 3, find an equation of the parabola with vertex at 0, 0, directrix at x equals 3, so it's a vertical line parallel to the y-axis, and focus at -3, 0. Okay. Now remember, this is my vertex is right there. For all of these at 0, 0, 0. The curve is always going to, the graph is always going to curve around the focus. So I actually can draw an equation draw a graph based on this description, but we want an equation. So we need a standard form. And so just be aware that you got to choose, do we want x squared equals 4py, or do we want y squared equals 4px? So you got to understand the difference of these two. When x is squared, the parabola is going to curve upward or downward. When y is squared, the graph is going to be a sideways parabola. So we don't want the x squared equals 4py here. We need y squared equals 4px. And we can see that our p value, p is equal to -3. P is always comes from the focus. So if the focus has a negative coordinate, then our p value will be negative. So I'm going to plug in. Y squared is equal to 4 times -3 times x, or y squared equals -12x. There's the equation of that parabola. And finally, just one more exercise. This kind of is just meant to take us back to something a little earlier in the course. How is the graph of the function f of x equals square root of x, which you guys should know pretty well, is a shape like so. It's related to the parabola x equals y squared. This graph is actually an entire parabola. Again, it's that standard form where y is squared and x is not. So it's going to be a sideways parabola, and you can fill in the details if you want here, but this is going to be like so. And of course, these two graphs are related to each other. In fact, if you take x equals y squared, that's the same as y squared equals x. I can just rewrite the two sides in reverse order. And if I take square roots here, y is going to be plus or minus the square root of x. Notice that plus or minus square root gives me y equals a positive square root, and we get y equals negative square root. it's helpful to start with the x equals y squared equation, because you see that when you take square roots, the y equals the positive square root is the upper half of the parabola, right? And the graph of y equals negative square root of x is the lower half of that parabola. Those are both square root functions. So f of x equals the square root of x is the upper half of the graph of x equals y squared. So we just wanted to circle back to that square root function a little bit and think about how those square root functions are halves of parabolas. So that's it. That's the end of our exercises for this section.